asking if anyone has a question, comment. Can anyone tell me? Yes.
Sorry, Professor, for the presentation, can you give us quick reminder what we're doing for the presentation?
Yes. Excuse me. Sure. Yeah, thank you so much for asking. So basically, each team will have a single deck. Okay. I expect the team leader or whoever you guys choose within your team to start this off. So when you start, he's like, my name is blah blah blah, and my team members, so and so, and you give us a high level of what you've done. Okay. We did autonomous vehicles. We searched prior art. Prior art meaning like what was done in this field. We got you guys like very high level. We got the major trend, and we got the security. So it's just like it's kind of like the team lead in the real industry when they give like a very high level overview. And if he or she wishes to go deeper in one topic, let it go. But rehearse prior. Make sure things will run smoothly. So John will present first, then Mary, then Anne, and which slide. So just appear as a coherent team. Everything has to be cohesive, okay? Then Mary will come with like, I'm going to talk about security, and that's been done. These are the vulnerabilities. Autonomous vehicle or drone in XYZ was hacked by method blah blah blah. But luckily, this startup or this company or this university, whatever, came up with this like wonderful solution that does this, and that. So basically, and once you finish the security, I'm just giving any example. It's your deck. You structure it any way you want it. And you say, I'm going to hand it over to my colleague, John. Then John will, yes, we studied like the technology trends, blah, blah, blah. Then John will hand it over to Anne, and Anne will say, we all worked on the simulation. And first, someone has to present the design. We presented the design. When the drones move away from each other, we expect the packet loss will be higher or will increase. Delay will increase, etc. So the other person will come. And we simulated the whole thing. We validated our design and our assumptions. And here are a couple of graphs that shows X and Y like this. And here's our firewall. I don't want to put like really tight structure. I want to leave it up to you guys to you design the whole thing. That's, by the way, that's how you build leadership and leaders. Okay, how you foster leaders? By not giving them like steps 1, 2, and 3. You give them the high level, and you encourage them come up with their own individuality. Okay, like either individuality totally on your own as an individual contributor or within a team. That's how leaders are created. But if I tell you exactly, I want the security to be second, I want the OBNet results to be third, and make sure you have only 2 graphs, and I give you the very tight instructions or detailed instructions, I'm limiting you. I'm not creating leaders. I'm creating followers. Okay? So you guys are the leaders. I wanted you to be, just be brave enough to take any steps in how to present it. think about it, see what makes sense to you. Make sense, guys?
Yes, thank you very much.
You're welcome. Yeah, just, this is your own thing. This is your own work. How you want to pitch it out to others, Maybe one of you or some team wants to go totally different from what I said. Surprise me. See, at work, guys, if you are if your manager tells you, do X, then Y, then Z, and you have to follow the same order. Then you become a manager one day, and you're going to tell your subordinates or your employees, do X, then Y, then Z. So you basically killed all creativity. Ideally, to create leadership and leaders, you tell them the high level. Like now, the high level ask, I give you a project, present it to me. Okay? You guys are totally up to it. And again, don't worry about the grades. Trust me. If I don't want to say this, but everyone will get the grade. Okay? Don't work just for the grade. Okay? Like I don't want you to be working. If you do this wrong, the professor will take points from us. No. Don't worry. Just don't be afraid to fail. Don't be afraid to make mistakes. You may come up with something totally different, and I don't like it. It doesn't mean I'm gonna get you the full grade. Don't worry about it. Okay? You have to fail in order to learn. So I'm just want you to be brave, guys. Do whatever. If it's not good, I'm not judging you. Okay? We're all here, including myself, to learn. Here to learn. So don't worry. Just do something that surprises me. Cool?
Yes.
Okay, good. Any more questions?
One more question, Professor.
Sure.
How long is the time limit for the presentation? Is there a time limit?
Oh, of course. So most likely each student will have 2 or 3 minutes, like last time. So each team probably will get let me send an email, as I said. Okay. Let me send an email so everything will be on the clear. But expect this to like 2 minutes or so.
Okay, thank you.
You're welcome. And this is very realistic. Trust me, guys. Trust me. I go in front of management, and I have to give a full presentation in 2 minutes or 3 minutes. And I can't speak fast, because if I speak fast, they're not going to understand me. So I have to squeeze exactly what information I want to give that person in 2 to 3 minutes. And after they listen, either they say, "Oh, it's good," or "bad." I don't take it personally. Like I presented something, me and a team, a couple of weeks ago. Presented 2 things actually, two small projects, not too small, like 2 projects within 6 minutes. Feedback we got, first one was you guys missed the ask. We did not really answer the exact ask, so the design was wrong. And the next one, the technical is good, but we failed to present a strong business case. Okay. And we don't take things personally. We're human. We're here to work, make things better next time. Things take time, iterations. So that's what I'm telling you. Don't be afraid if you do something that it does not really look good or something. As long as you try, just try. That's all. Don't worry, guys. No one is going to be penalized because you tried something new and it did not really make the cut. Okay? Venture out. That's the key word here. Yeah, but please not over 3 minutes. So we'll give everyone a fair chance to present their own work. That's my only requirement. Any questions? Comments?
It is 2 to 3 minutes per person in the group, right?
Yes. So each group will like if you're 4 people, I expect like what 8-10 minutes. So again, I expect that you guys gonna present on over 2 classes, probably the last 2 classes. That's why I'm saying, just let me know. Let me sit down and see exactly. So I send you clear instructions, so everyone would. I always like to communicate dates and final instruction via writing, just to eliminate confusion. That's all. It makes it easier for you and me. Okay. 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 So let's go back to the class, to the lecture. I mean, the technical material. Anyone remind me, please, where we stopped last time? Come on, guys. You guys can hear me?
Yes.
I'm sorry? No.
Yes, we hear you, Professor.
Okay, thank you. Can anyone tell me where we stopped last time?
So what I have on my notes last time, we talked about UDP and TCP and the packet loads when we use UDP and the
Thank you.
and yeah, that's it.
Okay. So we talked about the transport layer, right? Okay, guys. I always try to ask that question to see how many people studied. Okay. But thank you so much for answering. So let me recap the transport layer, like what we talked about in the transport layer, and guys, please study, okay? Because I'll tell you something great. I don't like to talk about the grade, but if you do your work on the project, so pretty much everyone will get almost like full mark. Maybe if you do like a very bad job in one aspect, I take 1 or 2 points, which is not really going to affect your grade. But what's going to make the cut in your grade is the final. Okay? I was very lenient on in the midterm because I gave you the whole. Although I gave you the whole exam, I was still very lenient. Okay? But come on, guys. I mean, at least you know where we stopped, right? That's the minimum thing you could have done. So in the past few lectures, we talked about layer 2. So when we talked about layer 2, we mentioned that it's very short distance protocol or set of protocols. Layer 2, so if you're sitting in a classroom right now with a computer, your layer 2 sees only the Wi-Fi router. That's all. Don't see anything else. come the total opposite is layer 4, the transport layer. The transport layer, as you guys see here, it's totally end to end. What does that mean? And I'm repeating some of our conversations, so I'm recapping some of our snippets, okay, for layer 4. Because we talked about layer 4 several times during it. So now you have your laptop open. You're checking your email address. You have your social media account. Let's have that, just those two applications. Where layer 2 only sees the Wi-Fi router, the access, the layer 4 sees from the application itself, like layer 7, from a layer 4. But don't forget, layer 4 is connected to the application via port. We talked about ports. That's why they talked about preparing you for today, for the transport layer conversation in general. So layer 4 here connects an application via port all the way to application in the server. So the transport layer bypasses all the network elements. So these are routers. So if these are two are adjacent physically connected nodes, the language here will be layer 2. So layer 3, the IP address, that will get the packets to the building. Imagine a building with apartments. So the IP address will get the packet to the building entrance. The transport layer, because it works on protocols, it will take the packets of the lobby, deliver it exactly to the apartment number, which is a port number. So in the example that I just gave you, someone has their social media and email on the browser. You're going to have two L4 pipes, or two transport layer pipes, each one to its own server. One reaches out all the way to the email server, that could be in California, and another pipe end-to-end reaching all the way to Texas, in case the email service company is in Texas. And each one mostly on a different port. That's how layer 4 knows, oh yeah, the packet coming from the email are going to the email client on the web browser. And the packets coming from California, from the social media network server, is going to the social media application or web page. That's the job of layer 4. Layer 3 would only tell the servers, oh, Joseph's computer IP address is like 132.17.18.19. And the packets will come. But they don't know where to go on to the application layer. They don't know where. That's the job of the transport layer. It will grab him from the physical layer at the bottom. It will look at the port number and will deliver him to the proper application. So you get end-to-end virtual tunnel. It's a logical tunnel. There's no actual tunnel, physical tunnel. The only physical connection is the physical layer. But you have to get used to the concept of virtuality. Virtual tunnel, virtual machine, virtual link, virtual address. Okay, we are living in a virtualized technology right now. And moving further will be virtual life. Okay, like with the whole metaverse and hologram calling and all of that. So just get used to the concept of virtuality, because you're going to stumble upon it. Not, but it is coming. Okay. So you have to get used to the concept of virtuality. Virtuality, that's something you can see. You can sense the effect of it, but it's not there. You know? Like a virtual machine. If you try to hold it with your hands, there's nothing to hold, it's just a piece of code. But it is there. How do I know? Because this virtual machine, I can log into it, I can send packets, it can do a lot of things. But it's not there. It does not occupy a personal space. So that's the virtual tunnel that we're talking about. You guys can still hear me, right?
Yes.
Yes.
Yeah, because my computer is the internet just kind of went down momentarily. Man, okay. So you may not be able to see my screen for a second. So back to my example, you have the social media network on your computer, and you connect it to a server in California.
Did he disconnect?
Yeah, looks like.
Yeah.
You guys can hear me?
Yes, we can hear you now.
Yes.
Yeah. I'm resharing again. So basically, from once your traffic leaves the network here in New York, actually your computer, all the way to California, you're going to pass over hundreds of network elements, tens or hundreds. Most of these are routers, L3 layers. And as you guys see in the screen, the virtual tunnel does not really touch the routers. What does that mean? So basically, each layer inserts its own header inside the packet. And each layer has protocols, and each protocol is different. So think of the protocol of a software parser, just to parse the software, the commands. Or just like a software, like a language compiler. So you have to have the right compiler or the parser in order to parse the bits into meaningful information inside the packet. So when I say that the line here, the virtual tunnel does not touch the router, that means that they don't get opened by the router. Why? Because these routers do not have a layer 4 software. Henceforth, they don't have layer 4 compiler. So if they attempt to parse the layer 4 header, which is like a bunch of bits, they're not going to see anything, because they don't have the proper algorithm or protocol. So they don't have the proper parser for it. So basically what I mean here, that the ones and zeros for layer 4, they pass over the network unopened, like still packaged. Okay. So any questions? Or is this idea clear?
Yes.
Okay. What else? So that's why it's very important for the application developer, for the app developers and the backend developers to specify which port. So your router and your device will know exactly what to do. Not router, sorry, with the host and the server. Like which application it has to move. Okay. So on layer 4, the vast majority of the applications they use one or two protocols, UDP and TCP. Okay. So UDP or TCP. However, there is a new algorithm called QUIC. Did we mention QUIC last time?
Yeah, I think you said it's like a mix between them two, something like that.
Exactly. Thank you so much for remembering. So QUIC basically is just mixes both together, and that becomes your new algorithm. So I like to talk a lot about UDP and TCP. I know we covered a lot of the aspects, but it's just very important to keep covering these. Okay? Because basically that's what I want you guys to get out of the course in terms of layer 4. That's what you get out with. TCP is very dependable. TCP is extremely dependable. UDP is totally undependable. And I gave you the example last time about the whole network was using TCP and failed. You guys remember that?
Yes.
Okay. I need more answers. Trust me. It's easier for me just not to repeat anything and just move forward quickly. Okay, but I try to repeat so I don't want anyone to be left behind. So at least, make me feel that somehow you're following. I mean, thank you so much for those who answered. But I have over 20 people here on the call, so okay. I'm just trying to go over and beyond, above and beyond, so you can understand. So TCP is connection oriented. Okay. So what is connection oriented? So let's go back in history a little bit. The internet in general, it was built to be connectionless. Can anyone define what is connectionless?
Without actual physical connection?
No. You have to have physical connection. But thank you so much for answering. But if you don't have physical connection, there's no connectivity whatsoever. No, I'll tell you what way. So let me first tell you about the connection oriented. Then I'll go back to the connectionless. So the internet was built to be connectionless. But let me tell you what's connection oriented, so you can understand what's connection. How many times you log into the bank, your bank account, and if you stay idle for like a couple minutes or 20 minutes or so, you get a pop-up message tells you, due to inactivity, we're gonna log you out or disconnect you in 20 seconds or 30 seconds. How many of you seen this pop-up message?
Like many times. Even not only banks, like many programs, not many applications online has this.
Yeah, like
Thank you.
even if there's also register for fast, you get locked out.
Exactly. Thank you. So this is connection oriented. Connection oriented. So the client, which is you or your application on your device, and the server in a full state, meaning they are connected all the time. What does it mean? It means there's like a virtual pipe dedicated to you. And the server on the other end, like if in case you're doing like some banking, it dedicates some resources like memory, CPU, bandwidth, just for Joseph's session. No one else, as long as I'm occupying that session, trying to do some business, no one can take this connection from me. So what happens in the background to keep a connection state, my application keeps sending to the bank, hey, I'm alive. The connection is alive. The connection is alive. Once I am idle for a certain amount of time, depends on the configuration, the whole thing gets disconnected. So that's connection oriented, okay? And that's what you get with the TCP. But the internet in general, it was built to be connectionless over UDP. What's connectionless? If you open the CNN or Fox News, would you ever get the message you've been idle for too long and I'm going to disconnect you?
No.
No, because you're not really connected. You're not connected to the CNN server. You're not. If you're idle, you're not connected. But once you try to click a link or something, you get connected right away. But it's connectionless. So if you don't do something, you're not connected. I'm not the CNN server or whatever, Fox News or whatever that news server, or Yahoo or Google, whatever that is, they're not really dedicated some resources to you. It's first come, first serve. But just to make sure the user experience is wonderful and pleasant, they give you a false feeling that you are connected. How? Can anyone guess how? They like a website that's connection less oriented, like in the background, there's no connectivity with the server, but as you as an end user, it gives you the feeling that you're connected. Can anyone tell me how?
Maybe like a pop-up. You have to interact with.
Yeah. So thank you. Yeah. So pop-ups, dynamic objects. So in the HTML code in the application, they're like objects. Like if you go to Yahoo, I guess you're gonna find like a clown moves or something, or like some object moves. Or you go to CNN, you're gonna find the pictures like move back and forth. So you're not actually connected to the server. So the server is not really sending all this dynamic objects to your screen. It's already sent it once at the beginning of the session, and it keeps playing dynamically off your computer. So that gives you with a sense of a live session. Your session is alive. But it's not. At the back end, it's not. When it becomes back alive, when you click on a picture or a link to open the news, once you click on the link, then let's go. There's an actual get. You know what's a get, right? Like HTTP command, like get, post. So you get a get like, get me this web page when you click on a link or a picture. So you get that only, okay, when you go ahead and click on something. But if you don't click on something, you're not connected. But you get a false feeling of you being connected. Okay? So that's how the internet was built. Later on came the TCP. But the problem with the TCP, as I mentioned last class, it is too tight. You know, so if the server can take 10 users and you create 10 TCP virtual links, and someone is idle long enough before you kick him out, an 11th person comes to try to log in, they're not going to be able to log in. So it's not really accommodating. And that's why I gave you the example last time. Whereas UDP, connectionless, but is accommodating. So as I mentioned also last time, you are the engineer. Someone asked me who determined that, right? So it's you. You as an engineer, you have to determine it. And let me show you something else. So I'll talk about reliability. So just to understand 100% before I move on this slide, UDP is connectionless, and that's how the internet was built. TCP is connection oriented. And you understand exactly what I mean with connection and connectionless from your exact experience. Okay? So let me talk about reliability. So big part of our telecommunication goals is reliability. Reliability mean what? Or means what? No bit errors. So if I send a 0, it arrives to you as a 0. If I send you 11 packets, you get exactly 11 packets. Okay? Of course, other measures of reliability would be certain delay, close to zero jittering, etc. But for the sake of these couple slides, these are my main two goals right now. So UDP is not realistic at all. Sorry, it's not reliable at all. But some application like the one I mentioned last class, you cannot run it on TCP. You just can't. You don't have the means to run TCP. So I am running an unreliable. So this is TCP. You're running in TCP. You have reliable channel, and this is your application. But what would happen if you are forced to use UDP, which is unreliable channel? That's okay. So you're asking me, can I create a online banking system with UDP? Yes, definitely you can. It's not recommended, but you can. How? By embedding the reliable aspect or reliability aspect somewhere. Normally would be on the application layer. Okay. So all the wonderful stuff that you would have with the TCP, like acknowledgements, data sequence, etc. You would embed that in your application. So when you write your application, make it very tightly controlled. So you shift the reliability into some other layer. Don't be adamant. I mean, that's what engineers do. Try to be dynamic. Okay? If you cannot achieve something on one layer, on one system, on one element, that's okay. It should not be the end of the world. You be very dynamic. You see where you can implement the same feature or the same functionality somewhere else. Okay? Questions?
Professor? Yeah.
Yes.
When you implement the reliable like on a different layer, does that mean like you're gonna use less resources? Because like with the other like layer it uses more resources.
Very smart question. Not necessarily. Not necessarily. It's kind of an advanced topic. So basically, I'll say it to you. So basically, in transport layer, you're using intensive networking. Okay, like you consume a lot of networking resources. But in the application layer, you could be very light on the bandwidth, but be very intense on the CPU. Okay?
I see.
So what does that mean? I know my answer wasn't 100% clear. So let me give you an example of what I mean. So basically, I'll give you like an example, okay? So let's talk about video transmission first. You have two options. First option to be bandwidth heavy. So each picture frame you send like duplicate. Okay. And now you're consuming a lot of bandwidth. But the CPU here is very light. You're not doing any CPU intensive. Or the other option, you send a very light picture, like compressed, and you run local algorithms on the terminals, and the CPU will have to run very sophisticated algorithms to reconstruct the pictures. You guys understand this example?
Yes.
Yes.
Yeah. So most likely, if you can reduce the resource consumption, that would be awesome. But in most cases, being realistic, you can't really reduce the resource consumption. But what you can do, you can shift them to somewhere else you don't need it. So in this example, if you have a lot of bandwidth, you can send like very high frame picture with minimal CPU processing. So for instance, you do this.
Like a company, for example, like Netflix, like would think like, for example, if everybody have like a smart like TV in their home, probably it's better for them to shift the processing to the smart TV than their network, right? Something like that.
Awesome. Because thank you so much, sir. This is really awesome. Exactly what I wanted to say. Exactly. But if you are sending to a neighborhood with certain demographics or age bracket, like older folks that they don't have a lot of money to buy fancy equipment, so what would you do here? You lean on the network to send the heavy picture with minimal processing on the user end devices. You see, because you're serving a demographic like most the 80% of the population in this zip code is like way below poverty line. Most likely their phones and devices like a couple or 3 years old. They don't have that much processing capability. So that's what you do. Okay? So this is the same thing here. And you as an engineer, you'll be encountering that all the time. Is like where to shift the load to. So if you can shift the load altogether, that will be awesome. That will be like right away either a patent, or if you're doing a PhD, that will give you a PhD. But if you can't, just try to move it intelligently.
So it has to be dynamic.
The way you think it has to be dynamic. Yes. So here, reliable channel, a light application. So here in this example, layer 7 is very light, but layer 4 is very heavy. When I say heavy, meaning a lot of packets back and forth, like acknowledgements, sequence numbers. Hey, you missed packet number 4. No, give it back to me again. It's just a whole lot of work. Where the application layer is like taking a back seat, relaxing, not really spending a lot of effort because all the reliability is being done at a lower layer. Come here, the layer 4 is very light because it uses UDP, which is very less intense CPU and resource intensive. However, the heavy lifting is being done on the application. Okay, maybe the application layer folks here are very smart, and they don't require as many acknowledgements as the TCP. Actually, someone was telling me about a project. It's very close to that. He works for another company. He's a friend of mine. There was working on video compression. So this startup came up with video compression technique just to lower the bandwidth. And according to them, it's not going to reduce the capacity. It's not going to reduce the viewability. So if we're sending you high def, it's going to stay high def. So it's wonderful from the technological point of view. When they ran the algorithm and start like testing it in a lab, they found the saving would be $30 million bandwidth. Okay, they're gonna save the viewers $30 million. Is that good or bad?
That sounds really good, Professor.
I'm sorry?
That sounds good if they're saving money.
Thank you so much for answering. I love that. But being an engineer, in many times, it like equates to being a judge. Okay? Just think of it that way. When someone tells you one side of the story, don't be quick in making a judgment. Trust me. A flawed judgment from an engineer could just bankrupt the company, or could just drive the whole company to ground, or even, God forbid, can cause losses of life. Okay? So here's the full story. Purposely, I asked, what do you think before I finish the story? Because I wanted you guys to expand your minds into the business side as well. But this company wanted $60 million for the software. You see the story now? And by the way, that's how That's how salespeople will get you as an engineer. You know, that's how they're gonna get you. They're gonna tell you it's gonna save you $30 million. It's gonna save this and that, and they rarely talk about how much this is actually gonna cost you. You know, it's like similar to timeshare. I don't know if you guys been to like a timeshare spiel, like you heard their spiel. It's the same exact thing. They tell you all the savings that you could get, or you'll get once you join their system or whatever. But they never tell you about the maintenance fee, the monthly maintenance fee, and the tax implication. They don't tell you the whole story. So that's the engineering side here. If you're an engineer and you have to make a decision between this and that, you have to give it a full thought. Okay? Part of the engineering work is not only design. Sometimes you have to choose between two solutions, not only based on technical basis, but also on financial or business implications, and also user experience. You know, at some point of my life, and actually still I am, I work on one of my titles as service planner. Service planner. So service planner, and again, I'm just telling you that to get you stumble on a job that requires service planner, so you know what that is. Service planner, you are going to design the system from the user experience perspective. Like imagine Zoom here. The service planner will say, yes, I want the chat button here. I want the functionality of mute someone. Things like that. So you as an engineer, you have to weigh on the design from a service planning perspective. Because this could be okay, could ease the load on layer 4, but increase the load on the CPU. And because of that, you cannot have so many buttons or so many functionalities to the user, because you're overloading the host. Okay? So this is nice just to show you how you can distribute your load. Any question before I proceed? So let me just recap user data grab protocol, UDP. So UDP is best effort. And please do not be fooled with the words best effort, because best effort is not really a good thing. Best effort means let's see what we can do. There's never a promise that something will be done. Okay? So every time in the telecommunication world you hear about a system that will deliver best effort, you have to understand what does it mean. Okay? So if a packet is lost, no one would ever know. If the packets are delivered out of order, no one will ever know. Or even they're not going to know, and no one really cares. We talked about the connection list and how does it look like. But the advantages are It's very light, very light, very simple. Headers are very small. Okay, you can transmit as fast as you can. So I put this here as an advantage, but actually many times it can be disadvantage. How? So I'd like to give the example to you guys. Like you just went, you bought your 1200 or 1400 super duper phone that has the latest and greatest hardware and software. Now you walk into a building, you try to communicate with devices to talk to a server, and all the way halfway around the world that's been there for 10 years. And that old server only talks 100 packets per second on UDP. Whereas your super duper phone talks 2,000 packets per second. So if they talk if they talk UDP, what is going to happen? Your phone is going to transmit the 1,000 packets, not caring about the receiving end. And the receiving end just can accommodate like 10 or 100 packets per second. So literally every second, you're dumping 1,900 packets on the floor. Okay. So this is really bad. Okay. Again, just that in my opinion, one of the more suitable cases for UDP, if you're watching like high def TV, like or playing like media rich e-game, like some gaming or something. So if you lose like few hundred packets every now and then, because you're using UDP, no one really should care because it's not going to impact your viewing experience. And if you're playing a game, you know, like one of these fancy games that, you know, people play online, if the loss is not consistent, and I'll talk about this in a second, you're not going to notice it. Or maybe if you notice it really, like one small object in the gaming, in the viewable screen will be blurry, a little blurry. But hey, and if you're playing games, everything is like moves so fast, right? So if an object or a couple objects are a little blurry, I don't think you're gonna even notice. You know, I don't think you're gonna notice. So this is like very strong use cases for UDP. And so in case if you're streaming or playing video games, these applications, so I'll go back here. Where is it? I'll go back here. So if you're using UDP, in the application layer, you have to have some mechanism. Am I gonna put like acknowledgements for every single packet when you're watching an extremely high def video game, movie, or play high def video game? No. But what you can do, you be smart about it. You put like traffic monitor or traffic counter or data rate sensor or software. So you know, in order for the users to have a nice viewing experience, they need to watch the movie on average, an average of 20 megabit per second. So you're using UDP, you're going to 18 megabit per second, 21, 24, you go back to 15, you're good. And then in the application layer, you say, you know what, if my data rate goes below 16 megabit per second for a minute, then I have a problem. So as long as you go up and down, you're good. You don't have to send like every single acknowledgement along the way. But you put a monitor, so that's kind of intelligence you put on the application layer to write over the top of the UDP. So I'll stop here. So you guys understood what I stated to you today?
Yes.
Yes.
Okay, I hope you guys are taking notes. Any questions? Okay, everyone. Have a wonderful and safe holiday. Enjoy. And happy Thanksgiving to you and your families and loved ones. Take care, guys. Enjoy.
Thank you very much.
Oh,
You too,
thank you.
Professor.
Happy Thanksgiving, Professor.